a new mystery in space. A mysterious, perfectly spherical object has been discovered. Our Milky Way galaxy is home to some extremely strange phenomena, but a recent discovery has truly surprised astronomers. In data collected by a powerful radio telescope, astronomers identified a bubble that appears almost perfectly spherical. There is a general idea about what it might be. This sphere is most likely a supernova remnant, SNR, the expanding shell of gas and dust created by the explosion of a massive star, driven outward by shock waves. While supernova remnants are not rare in space, this particular example is highly unusual because its shape is nearly a perfect sphere. How it formed so symmetrically, however, remains a mystery. An international team led by astrophysicist Miroslav Filipovic from Western Sydney University in Australia has named the object Teleios, a word meaning perfection in ancient Greek. After thoroughly examining the possible explanations, the researchers state that more data is needed to fully understand how this object formed. Identified as G305.4 to 2.2, Teleios was actually discovered by chance. While examining new images from the Australian Square Kilometre Array Pathfinder ASKAP radio telescope, which surveys the southern hemisphere sky, Filipovic noticed its extraordinarily circular shape and began investigating it in greater detail, symmetrical like a work of art. Using data from ASKAP and the Murchison Wide Field Array, researchers evaluated two possible size and distance scenarios for Teleios. If the remnant is about 7,175 light-years from Earth, it would have a diameter of roughly 46 light-years. If it is 25,114 light-years away, its diameter would be an astonishing 157 light-years. In either case, forming such a highly symmetrical structure would be exceptional. Teleios has a circularity of 95.4%, making it one of the most symmetrical supernova remnants ever observed. Although ideal theoretical models predict that supernova remnants, SNRs, should be circular, in reality they are usually irregular. This is because the explosion itself may be asymmetric, or the expanding remnant may interact with surrounding gas and dust. However, Teleios shows no signs of such distortions. Why so perfect? Its remarkable symmetry may be linked to its location. Teleios lies 2.2 degrees below the plane of the Milky Way, in a region relatively sparse in interstellar gas and dust. This suggests the remnant may have expanded freely without significant environmental interference. Yet Teleios' shape is not its only unusual feature. The supernova remnant has only been detected at radio wavelengths. Although faint hydrogen alpha emissions have been observed, there are no signs of emission at optical, infrared, or X-ray frequencies, which are typically seen in supernova remnants. This absence is puzzling for scientists. The analysis has been submitted to the journal Publications of the Astronomical Society of Australia and is also available on the preprint server ASKAP. Strange circles in the sky. As part of the Evolutionary Map of the Universe (EMU) survey, ASKAP has revealed various strange circular objects in the sky. Some of these, such as the well-known odd radio circles, ORCs, are located at intergalactic distances and have been difficult to interpret. Teleios, however, lies within the Milky Way, giving it a different origin from the distant ORCs. Despite being closer and therefore smaller, the uncertainty surrounding its exact distance remains a major obstacle to understanding its nature. Filipovic and his colleagues conducted a detailed analysis and found that the object glows faintly only at radio wavelengths. The characteristics of this emission suggest it is most likely the remnant of a Type 1a supernova, one of the brightest types of supernova in the universe. Type 1a supernovae occur when a white dwarf star in a close binary system accretes too much matter from its companion, exceeds a critical mass limit, and explodes. Distance complications. Determining distances in space is surprisingly difficult. Researchers were able to estimate Teleios' distance, but could not narrow it down beyond two possibilities. Approximately 7,175 light-years, or about 25,114 light-years. These two distances imply very different evolutionary histories. The farther an object is, the smaller it appears, which significantly affects estimates of its size. At the nearer distance, the remnant would measure 46 light-years across. At the farther distance, it would span 157 light-years. Supernova remnants consist of expanding clouds of material, so their size provides clues about their age. The nearer distance suggests a younger remnant, likely less than 1,000 years old. The farther distance would imply an age of over 10,000 years. However, both scenarios face a major issue. Evolutionary models of Type 1. A supernova remnants predict detectable X-ray emission. Since no X-rays have been observed, this creates a significant contradiction. A zombie star possibility? Another possibility is that Teleios is the remnant of a Type IX supernova. This is a subtype of Type Ia supernova that does not completely destroy the white dwarf, leaving behind a so-called zombie star. This scenario fits Teleios' emission properties quite well, but it would require the object to be much closer, around 3,262 light-years away. At that distance, Teleios would be much smaller, about 11 light-years across. There is even a potential zombie star candidate at that range. However, independent measurements suggest Teleios is unlikely to be that close. Rare, but not impossible. While these uncertainties are significant, they somewhat overshadow the remarkable symmetry of the remnant. Supernova remnants are almost always asymmetric. The explosion itself may be uneven, the expanding material may collide with surrounding interstellar matter, and eventually the shell begins to fragment as it grows. But if the explosion were highly symmetrical and occurred in a relatively empty region of space, the remnant could expand evenly. It may simply not have reached the fragmentation stage yet. Such cases are rare, but not impossible, which makes Teleios especially fascinating. According to scientists, more observations will be required to fully understand its story. The researchers wrote, "We conducted a comprehensive examination of the evolutionary state of the supernova based on its surface brightness, apparent size, and possible distances. All potential scenarios present challenges, particularly given the absence of detectable X-ray emission predicted by our evolutionary models. Although we consider the Type 1a scenario the most likely, there is no direct evidence to conclusively confirm any scenario. New, sensitive, high-resolution observations of this object are required." According to Filipovic, there are two possible explanations for the missing emissions. Either Teleios' temperature is not high enough to radiate at other wavelengths, or the remnant is so old that its optical emissions have already faded, leaving only radio signals behind. Based on current data, Teleios most likely formed from a Type 1a supernova. However, a Type 1ax scenario, in which a zombie star survives the explosion, remains a possibility. Still, the observational data does not perfectly fit any existing model.